Students, this is SAHA tutorial. I have started to launch videos on analytical geometry 3D. So I have already launched 2-3 videos on this topic. Now I again launch a video on this topic. So before starting this, please subscribe this channel. And if you like this video, then like, and of course share with your friends if you like, and if you have any suggestion then comment me. So let's start analytical geometry 3D. Today I discuss about projections in 3D. What is projection? First we study what is a projection of a point. So we need to take a plan. First we draw a plan in 3D. In rectangle Cartesian coordinates, plan is given by any two coordinates. So we have taken 3 axes first, OX, OY, OZ. 3 axes meet perpendicularly at the point O. If we consider the plan X, O, Z, and if we take any point O, any point P, which coordinate is X, Y, Z, then its projection or foot point is called the point which lies perpendicularly down on the plan or intersects at the plan. This may be Q. Q lies fully on the plan, so its coordinate y coordinate must be 0. It will be I am taking, just take, this will be x 0 y. So this is a projection on the x o z plan of P point. If we take a perpendicular on this plan y o z in this way, here the x coordinate is 0, so this will be 0 yz point. This is the these are the foot points or projection on the plans of the point P, any point P. And if we draw the plan on the XOZ plan, XOY plan, and this is S, then its Z axis, Z coordinate is 0. This will be X, Y, and 0. So there can be 3 foot points in 3D of any point on a rectangular Cartesian coordinate. So these are called foot points. Here S, Q, R, S, R, foot points, or projected point. Or projection. of P on the plans. P, sorry, P on the plans, on the coordinate plans. So this is the projections of any point. Now we'll try to find out the projection of any straight line coordinate plan. So let's take an uh, diagram. There are three rectangular Cartesian axes: OX, OY, and OZ. Now we'll draw a parallelepiped parallelepiped in this way, which are parallel to, this side is parallel to y-axis, this is parallel to x-axis, and this is parallel to uh, z-axis. Now we are drawing a parallel point. Now again this is parallel to y-axis. In this way. These are parallel to y-axis. This is parallel to z-axis. These are parallel to x-axis. This is also parallel to x-axis. This is parallel to y-axis, and this is parallel to x-axis. So this is a parallel point, and this is parallel to y-axis. So we will take, this is P and this is Q, and this is the diagonal PQ. Now I have already found out in a video that what is the distance of the PQ in 3D in another video. So must watch those videos. What I have tried to find out here, uh, the projection of the straight line on the on any plane like x x o z plane. So what will be the projection of PQ? What will be the projection of PQ? What will be the projection of PQ on the XOZ plane? So if we draw a perpendicular, this is the perpendicular, this is the perpendicular on XOZ plane from the Q point to XOZ. So I'm taking another diagram to clear it. It is much better to take another plan. I'm taking a plan just. This is a plan. Any plan, coordinate plan can be XOZ or XOY, and separately taking PQ point. This is P and this is Q point. So here I have to take more curve. This is the point PQ. Now, if I wish to take projection on this plan, then I have to draw a perpendicular P from to this point. This is P slash, and from the point Q, this will be Q slash. This is Q slash. Now, if we continue to draw a line which intersects through QP, which intersects the plane at the point O, and if we join the line O P slash Q slash. Then the projection of PQ is denoted on the plan X, Y, Z, on the plan X, Y, Z, uh, L, on the plan X, Y, Z, L. The projection of the line segment PQ is called P slash Q slash. So any line segment projection on plan is the joining. So here we have two foot points, two end points of the line joined by the 2 points. There are 2 points PQ joining this line, joined by this line PQ. There are two foot points P slash Q slash, and the projection is the join of the two foot points of the two end points of the line. So joining of the two foot points of the end points of the line. End points of the line. So how we can represent the the line segment with respect to the projected projected line segment. So if we extend the line segment QP to the plan which intersects at the point any point, let's say take O, and the foot points joining line segment if extended to point O, then if we get a angle theta there, then you can very easily understand that if we compare these must be perpendicular, these both are perpendicular, so must be parallel. So here we can take PQ by P slash Q slash is equal to OQ by OQ slash. So this will be equal to 1 by cos theta. So we can get the projected line segment is equal to the line segment PQ cos theta. So in this way we can find out the projected line segment of any the projected line segment of any line. So in this way we can also can calculate in 3D also of any line segment PQ on the coordinate plans in this way, but it is hard to understand. That's why I separately make you understood that how projected line segment can be obtained from a line segment. So let's see now what is direction for some definitions I wish to clear now, that what are curves, when we will get curves and when we will get surfaces. Curves and surfaces. 3D surfaces. So if in a 3D vector Cartesian coordinates, if any point P given movable point P, its locus, which is represented by equation fxyz, where P is a movable point, is equal to 0. It is specified as a equation, a single equation, just a single equation. All the points are satisfied a single equation. Then and the locus of the P, then the locus of the P is called the surface. The the locus of P represent a equation of the surface. The locus of P represent a surface, and this equation is called surface equation. Represent a surface. So in this way we can obtain a surface and the surface equation. But if it happens that here I used to clear that what is cylindrical surface. It will take fxy is equal to 0, then z can be any point. Then what we will get, if this is x and this is y and this is z, this is the origin, then z this equation represents for every value of x y, we can take a single equation. Then we will get a movable curve which intersects by straight lines, So this is called cylindrical surface actually. Here it can be any value, and cylindrical surface, where this is the equation, this is represents a surface on the xy plane. So xy plane, this represents a surface, actually a curve, sorry, not a surface, a curve, and all the lines passes through this curve parallel to z axis represents cylindrical surface. Cylindrical surface. So this is the definition of cylindrical surface. Now what is a curve? Curve is that if we get two equations, like if we have two equations, f1 xyz and f2 xyz is equal to 0, then if any point by any point, if this is satisfied by two equations in 3D, then we will obtain a curve. So a curve in 3D is described by two equations of any variable, movable variable, by two equations. Uh, if any movable variable or any movable point satisfies two equations in such like, then it represents a curve in the 3D. It represents a curve in 3D. 3D. So these are the topics, and in short, I'll giving some information about direction cosines. What is direction cosines? Direction cosines. Direction cosines are in this way we can define direction cosine. Just take this 3D of the vector Cartesian coordinate O, X, OY, and OZ. Then any point P is coordinate is X, Y, Z. So this line segment, uh, this line OP's direction cosines are described by the angles made by the point, the line OP. There are three perpendiculars. You can watch this on the axis, like this is Q, QR, QS. So this there are three angles. PQ, OP makes with x-axis this is alpha equal to, then with y-axis it makes beta angle, and with z-axis it makes gamma angle. Then these angles alpha, beta, gamma are called direction cosines of the line OP. So how these are represented? Alpha, we have cos alpha. Cos alpha will be actually this, if we join this, then cos alpha will be this is x, this is y, and this is z. So if this is the coordinate of this point, then this is x, this is y, this is z, then cos alpha will be x by OP, and cos beta, alpha, beta, gamma are the angles. Now these are direction cosines, but cos alpha, cos beta, and cos gamma are called direction cosines. So these are called direction cosines. These are the angles with respective axes with the line OP. So cos beta will be R is T. So this is Y by OP, and cos gamma is Z by OP. So these are often denoted by LMN. These direction cosines are denoted by L, M, and N. So if we add these, L square plus M square plus N square, so we must find out that there will be in this way x square plus y square plus z square by op square. So these sum we know from the earlier concept that this is equal to p square by op square. So this is equal to 1. So sum of the squares of the direction cosines must be equal to 1. So we have to remember this, the sum of the squares of the direction cosines must be equal to 1. Now many properties related with the direction cosine. I just finish with the last topic, talking what is direction ratio. This is also very important in senior study of analytic geometry. Direction ratios. This is equivalent to direction cosine, but it has its own significance. Direction ratios. So if L, M, N are direction cosines, L, M, N, then if any three numbers A, B, C, which are proportional to L, M, N, then what we will get? We will get a relation L by A, M by B, and N by C. So all all the direction yeah, they are proportional in such a way that they have a common constant. Uh, all the direction cosines have a common constant. Means all must be equal to a common constant. So all their I mean to say that their ratios of direction cosines with these numbers L by A, the direction cosines, and the number B, and again the direction cosine and the number C, their ratios must be a constant. So these are called, then A, B, C are called direction ratios. Now we have a relation that what will be now if we use to know the value of k, then k can be denoted by, if we take L square plus M square plus N square, then it will be here k square into a square plus b square plus c square. So I already proved that this sum of the square of the direction cosine must be equal to 1. So this is 1. So k must be plus minus 1 by root over a square plus b square plus c square. So from this we can get the relation of direction cosines and the relation with this number. So L must be plus minus A by this root over A square plus B square plus C square. In this way, M is equal to plus minus B by root over A square plus B square plus C square, and N is equal to plus minus C by root over A square plus B square plus C square. These are the relations with the direction ratios and direction cosines. Very important layers must remember. And one thing is to remember that if we take positive sign, then all for all the direction cosines must be positive. And if we take negative, then all the direction sign cosines should have a negative sign. So there is a restriction in taking the sign that we are taking positive or negative. All should be positive or all should be negative. Yeah? Thanks for watching. चलो क्रिएट करो चलो 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 बैट बॉल नहीं चलो और खेल चलो